This is another video for Math 2-3. This is solving quadratics part 3, and this is when all three terms, A, B, and C, are there. If we look at this quadratic that we're given, please notice that there is an x squared term, and the value of A in front of it is 1. We just can't see it. And then there's bx, where b is 7, and cx, where c is 12. So there's the x squared term, the x term, and the constant. And notice it's all set equal to 0. That's really important. So the a term is there, b term, and the c term. What we use here is what we call factoring. We're going to factor out two linear factors. They're called linear factors because each one is the equation of a straight line. So we make two parentheses, two sets of parentheses. This is how I always start these. And since this is an x squared here, we know that when we use the distributive property, we're going to want to use x times x to get that x squared. And then we want two numbers that when we multiply together we get 12. But which two numbers? Because there's more than one possibility. We've got some things called factor pairs. We've got 1 times 12. We've got 2 times 6. And 3 times 4. Well, examining these, there's only one of these pairs that when I add them together, I get 7. And that's my clue. I need a pair that when I multiply them, I get 12. And when I add them, I get 7. So, examining these down here, I'm going to do this the long way, but it probably jumps out at you already. 1 plus 12 is 13, not 7. 2 plus 6 is 8, not 7. But 3 plus 4 equals 7. So those are the numbers that I'm going to use. This is x plus 3, and this is x plus 4. Or we could do it backwards. Because multiplication is commutative, it doesn't matter what order we do these in. This could be x plus 4, and this could be x plus 3. Both ways would work. So here's the factored form of the quadratic equation. We're not done yet. We haven't found the values of x. It's quick from here though. What we need is a mini equation here. We need to figure out what value of x we would put in here to make x plus 3 equal to 0. And the long way, which I'm not going to do every time, is looking at this. When we solve this mini equation, we get x equals -3. But we're trying to find a pattern here that will help us solve these quadratics much more quickly. So please notice that this x equals -3 is just the opposite value of this +3. If there's a +3 here, there's a -3 here in the solution. This is the factored form, x plus 3. So the solution is x equals -3. Because when we plug in -3 for this x, the result is 0. And that's what we're looking for. So moving right along, x plus 4 gives us x equals -4. And there's our two solutions, x equals -3 and x equals -4. Here's a similar problem. This one's different in that there's a negative in the middle. So we got to do a little bit more work to figure out what the values are here. We need two numbers that multiply together to get 14. Let's see what the possibilities are. How about 1 and 14? Or 2 and 7? Well, when I add 2 plus 7, I get +9. And I'm looking for -9. So what we need to realize is that there's more than one way to get +14 out of 2 and 7. We could also have -2 times -7. And when we add those together, we get -9, which is what we're looking for. I'm ignoring this for now because it wouldn't get negative 9. So, x minus 2 and x minus 7 equals 0 is the factored form. And that gives us, here the x minus 7 means that I would plug in positive 7. So x equals 7 is one of the answers. And here, x equals 2 is the other answer. And yet again, here is a quadratic that we're given. I think it can be factored, so I'm going to start off with 2 sets of parentheses, equals 0. But now, there's a negative over here. That means that when I try to factor this, in order to get a negative number over here, I need to have one positive and one negative. That's the only way to multiply and have the result be a negative. So I've got 1 and 6, but one of them has to be a negative. So these are 2 possibilities. When I add 1 minus 6, well, I could also have 2 and negative 3 and negative 2 and positive 3, and those look like they'd be involved in 5, adding together to get 5. But let's see which one of these works. 1 plus negative 6, that would be negative 5. 2 plus negative 3, that would be negative 1. Negative 2 plus 3, that would be positive 1. So the only one that works here is negative 1 plus 6 equals positive 5. So those are my answers. This is the factored form. That's the factored form of this quadratic equation, which leads us to our solutions. Here's a better way to write the answers here. We know that x equals negative 6 or x equals positive 1. Those are the answers. Those are the 2 values that if I plug them into the original quadratic equation, the answer will be 0. And that's what we're looking for. So that was 3 different examples of factoring. Some of them had negative numbers in them. Not all equations, though, not all quadratic equations can be easily factored. In fact, not all quadratic equations can be solved at all. And we'll explore that more in the next part, which is when it can't be factored, you use the quadratic formula.